Hey everyone, welcome to today's another technical stream which is on Intro to GraphQL. So excited to have all of you here and can't wait to start talking about all the interesting things around GraphQL. So excited to have so many of you here. Before we get started, I just want to make sure that all of you have checked in for the event. So you can see the link on the screen there, hackpack/GraphQL intro. Can you please make sure to first go there, register and check in, and we will immediately get started with the workshop slash live stream soon. So what I have in mind today is that we sort of go over and have more conversations about GraphQL and try to understand it. And we won't be doing a lot of heavy lifting code writing today. So we won't really use a lot of JavaScript or Java, and we won't stick to a specific package because I want people from all different kinds of programming languages backgrounds to just come here and develop sort of basic understanding of what GraphQL is, what it means, and how you can just better use it in your projects, right? So before we get started with that, I wanted to get an idea here about what everyone's background in GraphQL is like. So can we have some comments in the chat about whether you all have worked with GraphQL before, if you've heard of it, if you've read anything about it, just let me know where we stand and we can talk about it more. And I would love to interact with all of you and maybe even bring you on stream if you have more to say, and we can just discuss and talk about these new amazing technologies that we have coming. So excited to hear what all of you have to say. And then I would like to share a few links with all of you as what we will be looking at right now. So it's good that you all have heard about it, but you've never worked with it, which is exactly why you're here at an Intro to GraphQL live stream, right? So yeah, it's nice to see that you all have heard about it before. So let's basically go over, and I know that a lot of people here who have heard about GraphQL have probably worked with RESTful APIs before. Is that the case with all of you? I'm guessing if you have written any backend code and you've built web applications, then you've written some sort of RESTful APIs. GraphQL is designed to make APIs fast. Yes, that's very true in a lot of cases, and we'll just walk over that. And it's good to see that you all have worked with RESTful APIs. So let me share a little bit of my screen and go through a couple of things with all of you. Just give me 1 second to wrap that around neatly here. Okay. All right, and just so we have this, and then we have this here. Okay. So I have a bunch of stuff open here. So let's just, hey everyone. Hey, thanks for joining right now. Okay, so let's just share the screen and okay. So here we go. Voila. So as you can see here, I have this long documentation sort of thing open here. This right here is the GraphQL specification. So I have this open up here so that we can better understand what GraphQL is, and it's going to answer a lot of questions that you all have regarding it right now. So as you can see in introduction right here, this is the 2021 edition. There's also a working version of it that's not released. So we will take this as the officially released latest version. Okay, yeah, would love to actually share links with all of you. Here is the link in the comments about the GraphQL specification. All right. So basically here you can see that this is the specification document, and here it says that GraphQL is a query language and it's an execution engine originally created at Facebook in 2012. And now if we sort of go over to the overview, you can begin to understand that it is a language that was designed to build client applications. But the good thing about GraphQL is that it's language agnostic. So this means that because it's a sort of, it has a flexible syntax, it has a flexible structure, there is no particular language that you're supposed to use with it. And GraphQL in itself is not a programming language. Like, you can't just do computations with it. You can't solely alone use GraphQL. So you take the structure of GraphQL, the specification that it provides, and there are all these rules that you have to follow and all of the stuff that we can read or briefly go through in today's workshop. And then we can use it on top of other languages like JavaScript, Java, Python, C++, Rust, and try to build GraphQL APIs with it. So, like you can see right here, it's not a programming language capable of arbitrary computation, but instead is a language used to make requests. So today, what we will focus more about is how to understand this language that GraphQL has. There are queries, there are schemas, there are different types, the mutations, resolvers, a lot of these words that you're going to hear around. What all of those mean and how we can just use them. So if you are very keen and very interested in going into the depths of it, you can read the whole specification document. All different languages for which you might want to use GraphQL already have a lot of GraphQL packages, which are created by keeping all the different specifications by the GraphQL team here in mind. And then they build packages on top of it that people can easily plug into their projects and work on. So like I said, today we won't be focusing on any such thing, but instead we'll be using something called a GraphQL playground. So this is like a sandbox environment. This environment is, I'm actually using an environment provided by Eve Porcello. She is a GraphQL teacher and she runs these GraphQL workshops. She has a 5-part free GraphQL email course from which this playground comes from. So I don't want to give her full credit. I didn't create this playground, she did, but I'll be using this to talk about the different concepts of GraphQL. Hope that makes sense with all of you. And obviously I'll be sharing a link with this very shortly. But before we dive more into GraphQL, I think it's worth also talking about and understanding what are RESTful APIs and in which situations should you use what. Because there is a lot of debate around GraphQL and RESTful API and where should you use what and which buzzword should you be running towards. So let's take a look at what is a RESTful API. I like this very small article by Red Hat because here they briefly talk about what API is considered a RESTful API. So basically what REST is, it's not a protocol, it's not a query language, it's just a set of architectural constraints that are put on API developers. So if your API is following those constraints, then by definition your API becomes a RESTful API. So you can see the constraints here. It's like you should have a client-server architecture, a stateless client-server communication, which basically means that your server is not storing any state data of the client in a way that one request does not remember the response of the previous request, right? And there's cacheable data and there are layered systems, and you use HTTP protocol to send requests and receive responses, right? So that is RESTful API. But let's talk about how is GraphQL different from it. So, well, for starters, GraphQL has a very on-demand structure, which means that you can clearly tell your server that this is the data that I want and this is the only data I want. And it will structure the data in the format that you want it to, and it won't give you any information that is unnecessary. So let's take an example. Let's say that you were to make a request for, let's say you have a library and there are a bunch of books in the library, and the database stores the names of all the books, the authors, the summaries, everything. But all you want is a list of all the books in your library that you have. So you just want the names. But if you were to make a traditional request to a RESTful API, what it would do is it would fetch the information of all the books from the database, and it would send you all the information. So you would get all the names, the IDs, the author, everything. There is no way for you to sort of differentiate that I just want a specific piece of the information. And what this ends up doing is it ends up creating a very heavy payload, which in the end slows down your application. Now, obviously, you could always tell me that a solution to this is that you can create different types of endpoints where you can get just the names of the books, names of authors and books, and so on and so forth. But if you think about every permutation and combination out there, that means you have to write a lot of endpoints, and and every time that your client changes and the requirements of the client changes, you also have to change the server along with it. This can become very troublesome, which is why this GraphQL specification like enters the scene, right? So the great thing about GraphQL is I know I'm like talking a lot, but I'm just like trying to sort of set up a basic foundation here so that when we play in the playground, which we will, and which will be quite fun, I guess, then we can have a better understanding of what we're actually trying to achieve there. So the thing is that if you use GraphQL, what you can do with it is you can just have your server fetching all the data from the database, but you can have your client, which is your front end, control how much data it wants from the server. So if you just want the books, you're going to ask for the books and you're going to get just the books. But now suddenly as a client, your requirement might change. You might need not just the book, but on the home page, you might want to put up both the author as well as the book's name. So now you want both the author and the book name, and you can just change that one tiny thing on your client. You can just tell the server from the client that I want both the book and the author's name, and the server is going to give you that without you having to make any changes on the server. And that is what makes GraphQL a useful thing, that it reduces the size of the payload and you don't have to get any unnecessary details from the server that you wouldn't need otherwise. So it sort of helps to like speed up the performances in general, because not every device is using 5G internet, not every device is like an up-to-date MacBook. So keeping all of those in mind, it's a good thing to use a GraphQL API. But at the same time, it's sort of important to understand where GraphQL APIs can be problematic. One I've personally faced this and it can get quite frustrating. A thing that's not very convenient to do with GraphQL APIs are file uploads. So basically, because GraphQL is just a specification, a lot of things are open. And when things are too open, it's a good thing, but it can be a bad thing at the same time. So for file uploads, you have specific packages that are trying to handle it, but it's not as straightforward as RESTful API file handling is, right? So if you are working on a solution that is very file upload heavy, GraphQL might become a little tiresome. Another approach where GraphQL is not the most useful is when you're working on a very simple use case and you see that much is not changing. You sort of need the same kind of data all the time, and there are not going to be a lot of movements around there in your requirements from the server. In that case, again, it could be useful to just stick with RESTful APIs. But if you're working on any sort of project where the requirements of the client can alter at any moment, and you want to have a good flexibility between the client and the server, and you also want to write as little code as possible on the back end, then GraphQL is a good place to start. So I hope I've sort of like covered the grounds here. If you all have any questions before we get started with playing on the playground, I'm like ready to take up those before we start. I'm so sorry to hear that you can't hear me well, but I hope you can watch the recording later and join in the conversation. Currently, to everyone who's like joined the stream right now, we're just discussing what GraphQL is, when should you sort of use GraphQL over REST API, when should you use RESTful APIs over GraphQL. So if you have any questions around those, please feel free to like hit me up with them. And then we can start playing on the playground. Oh my god, I said that too often. I need to stop saying it. So this is the playground that we will be using, and the link to it you will find in the description here. Oh, one another great thing about GraphQL I forgot to mention. You don't have to write a lot of documentation by yourself. I mean, like a lot of custom documentation you will have to write. But any documentation regarding the API, be it like, what kind of data types you have, what kind of queries you can make, all of those things, you don't have to worry about it. Look at this. You have a docs tab here in the playground, and you just get all the queries you can do, the mutations, the subscriptions. It's pretty cool that way, and you have your schema right here. So again, don't get afraid from like all the words that are here. We are going to talk about them very shortly, and we're going to discuss like what all of them mean. But I would be really happy if you all have like questions and if we like talk about them. Okay, so sorry, I'm just gonna adjust this here. Yes, so I'm assuming that we don't have a lot of questions. So I'll just give you like 2 minutes to get on the playground, and I'll talk a little bit about where we're getting started. Okay, so once if you're going to just give me a heads up if that you're ready to go, so then we'll start talking about it. You will see that a major difference, yeah, definitely, that's 100% understandable. So if you have any questions about whether you don't sort of grasp what GraphQL means, or why you'd want to use it, let's talk about that. Okay, can I give a project example for GraphQL? Okay, so let's take the example of, I can think of like real projects I worked on, but it'll be too complicated to explain here. So let's take any normal example that, like I was talking about a library, right? Let's talk about a library management system, and I built it on the web, and it's like there's a lot of data that's sort of in like the how is it useful in web. Okay, so basically GraphQL helps you with creating APIs. So, and you need APIs on web applications to fetch data. Now where it is useful is where, say, you have a lot of different kinds of data, and you have different relationships between that data, and now we want to from the client side, from the front end, we want to call that data. But the structure, it's like we might want to call the, like, let's say you have a collection of documents called books or authors, and now this is like the same collection, and it has all the information, but depending on the page that you're on, your front end might need different kinds of fields from the database. So again, like I mentioned before, in the case of a RESTful API, if that was the case, you would either have one endpoint, and you would fetch all the data from the server. This would mean that you would end up getting a lot bigger payload than you desire. Or the other situation is where you would create multiple different kinds of endpoints with different kinds of payloads. That would mean that you end up writing way more code in trying to think of different possibilities and permutations and combinations. With GraphQL, you write a single type of query, and you just use that query to get different structures of payloads. So you don't have to worry about, you don't have to worry about how big it'll be or if it'll have useless information, because you get to choose how much information you fetch from it. Does that make sense? So again, like if I'm giving a project example, if it's an online web library management system, right? So on the homepage, you might want to display a list of all the books. And then you might have like a search system where it might query things by author. And now you might want to display the names of the books and the authors. But now when you click on that particular book, you might want to give out like all the details about this one particular book, right? So here you can see that it's just like this one database that is being used. And technically you just need to make this one call to your books collection and get the right information from it. But if you use a traditional approach, then you can end up having a heavier payload than your front end needs. So does that sort of make sense? And does that give an idea, or should we think of like more examples? Because here, this is a real GraphQL API on the playground that you see here of a fake ski resort. And that's what we're going to do. We are going to talk about the different things in this ski resort, right? So let's start with that. So like I said, in GraphQL, you don't have requests. And actually, another interesting thing I forgot to mention. In GraphQL, you only have one endpoint. So let's say in this case, this is the endpoint of the API. And this is it. Like this is the only URL that your front end knows about. And then when you go on this like URL, traditionally, if you're traditionally setting up GraphQL, your package might come with a playground setting like this. It's very similar to using Postman when you're making RESTful APIs. So yeah, let's talk about this one URL. How do you get different informations from just a one endpoint? Because if you are familiar with RESTful APIs, you know that for getting different kinds of informations, your API URL needs to look different. So if this was RESTful, and if I wanted to, let's see what we have here. If we want to get all the lifts in a ski resort, right? So what we would have to do is write all lifts, and then this was the endpoint that you would make a request to, and it will send you the payload. And if there was a particular ID that you would want, you would maybe make a query here which goes like ID should be this, and you would get from the lifts an ID like that. Or here you might have another endpoint which might be called get lift or something, and then you would provide it the ID here, or you would provide it in the body. And basically you sort of understand where I'm taking this. How you send requests in RESTful APIs is not how it works in GraphQL. So what you instead do is to this particular endpoint, you write queries. So those queries now look like you will write a query here. And now from here in the documents, you can see the queries that we have available. So let's say we have all the lifts queries. So you have all the lifts here. But now you are telling GraphQL that, okay, I want to fetch query for all lifts, but like what more? Like you can't just leave it at all lifts. If I try to play this here, then it's going to it's giving me an error. It should traditionally give me an error. Right now it's not working. Let me just try to see if it gives us data. Yeah, okay. So like you saw before, like if I just write all lifts, it doesn't really do anything for me because we're not providing it like from the lifts query, what information do we need, right? So if we put name here, and we can see what all we can get, right? And let's say we put, let me open lift. Okay, we have the status. And if we play this here, so now what we get as a response is not just the name, but also the status, and we get it for all the lifts in the ski resort. Now, one thing that I'd like to make clear here is that this does not talk about the implementation of how you would get all lifts. Okay, so the code implementation of how to get all the lifts relies on something called a resolver. It's something that you write in the language where you're implementing GraphQL. So say you're using MongoDB and you're using JavaScript, right? So there will be a resolver which helps you get all the lifts from the MongoDB, and it would give it to this particular request. This particular query. Every time you make all lifts query, it would go to another resolver, which goes to your actual database and gets all the lifts from it. But then what the GraphQL on the server side would do is it would see that, okay, the user is only asking me for the name and the status. So even though I have a lot of information, I don't need to send that to the user. I just need to send it what it asks for. And then if you also say you want the capacity, you can get the capacity. And it's just it's changeable that way. And you can see the example here. So that is how querying would work. But now here, if I want to do another query, because here in the documents, you can see all the queries that are available, and we have a list of these queries. And I'm just going to talk briefly about how they are structured as well in a minute. So let's say after the lifts, we also want to get all the trails, and we want to get the names of the trails and the difficulty. Yes, and the difficulty. But now it doesn't let me run it because now we have two queries with the same name, so it doesn't know which one to run, right? So I can give my query a name, which is called get lifts, and it's called get trails. And this right here, by the way, is the GraphQL query language. This is the one thing that remains common irrespective of what language you're using it with, which is the reason why I chose to just talk about this. So now here we can see that we have two different queries, and we can choose to run either of them. So here are all the trails we have and everything. Okay, we have a few questions here. Yes. So is there a database in the playground already? Yes, there is. So like I mentioned before, I am using a playground thanks to Eve Purcello. She has a free 5-part email course of which this playground is a part of. So I'm using that. So what this does is it actually has it's on this endpoint, and all of these queries actually go to the resolver calls that I was talking about, and they get the data from there. So right now the purpose here in this playground is to just understand how the GraphQL query language works, and not I'm not getting into how we implement it, because once we first get a better understanding of like how to play with this language, we can then build anything with it depending on whatever language you're using.
I found this on the web.
Okay, sorry for my Siri. Is this better now? Or actually what I can do is, yeah, wait a second. Yes. So is this more readable for all of you? Okay. All right. So I'll just like switch back and forth between my screens now. So sorry if it was hard to read before. Okay. Can you tell what are lifts and trails? Okay, it's actually a fun question. It has nothing to do with programming, but let's go here. So if we look at ski resorts, so just a second, ski resort lifts. So in a ski resort, these things that you see that take you up a slope, these are called lifts. And trails are the slopes that you can come down on. But in a mountain, you can't just use any path to come down. I mean, that'd be risky. So ski resorts actually have like proper marcations and trails made for like places where people can go down on. So that's called a trail. So yeah, like I said, because I'm using Eve's playground here, they have created a GraphQL API for a fake ski resort. So that's what we are working here with. Okay, so if this is sort of clear to you about how we get data from GraphQL, we get it via queries, and this is how we write them. And if you have multiple queries, you would have to name them, else GraphQL wouldn't know which query to run. Okay, so all right, because I zoomed in, I can't see the docs. Okay, so now here, I want to talk a little bit about the structure of the queries here. Like if you see the query, how do you type it? How do you define it? Let's talk about that, because every GraphQL packages requires you to first define what a query looks like and what types it has. So for instance, you can see here that this is a type of a lift, and we talk about what different fields this lift is going to have and what are going to be the types of each of these lifts, right? So I'm just going to copy paste this here, and let's talk about it more in this space. Okay, so we have a lift type here, and here the ID has an ID type because GraphQL has that by default. Name has string, status has live status, which, like you know, here we can create another type, and we can define that status is a string. Okay, now we should talk about what the exclamation mark here means. The exclamation marks means that it's a compulsory field, that for this particular, for a set to be under this type, this data needs to be there. It cannot be null. So that is what this type lets us do. You can't define a null field to status. Okay, another symbol that you might be seeing here that's a little different is the square brackets that we have. So the square brackets, anything that you write inside a square bracket means that it's a list of that things. So when we have trail in square brackets here, it means that trail access is actually a list of trails. And so usually the notation that we're used to seeing around is this. But just wrap your mind around that whenever you're writing anything in GraphQL, this is always like a particular type is always going to be written inside of square brackets. And then we can see that there are two exclamation points here, this one and this one. So this means, so this here indicates that trail access is a list of trails, and this list, in this list, the trail cannot be non-null. So sorry, the trail has to be non-null, like it cannot be null. And at the same time, it checks that this list itself is not null. So there are two checks that we make here. In which case, if we had an empty list here, that would be completely okay, because an empty list is not null in any way. It's an empty object. It's not undefined, or it's not null. So that's the basic that we have here to define the different types. Okay, do we have any questions around this first? Is getLifts the name of the query? Okay, so getLifts is the name of the query that the front end assigns it. It is not the name of the query on the server, and the server does not care about this name. So this is only a name that we on our front end care about, because if we were to just say query here, there'd be a lot of queries, and like the server wouldn't know, like there'll be like a conflict because there is no name given to the query on the front end. So this is the name that's given to the query on the front end, and this all lifts is the name that the server knows on the back end. And so, for example, here you could have another that gives you just the lift status, but so on the front end it would be a different query, but on the back end you don't have to do anything different. You just use the same all lifts query, and you just get the name and the status out of it. Sorry. And you can still run this and there'd be no errors. Okay, wait, there are errors because we have these types here, which we would have to remove temporarily. Get lift status, and you see that this works. And at the same time, if I wanted to get more stuff, I could just do get lifts. Okay, right? When are we querying the DB? So the database is being queried when all lifts here is being sent. So when this query is sent to the server can then decide how to resolve this query, right? How does the server send the data to the front end? It can be done, like it's possible that the server did some caching, so it doesn't have to send another request to the database, or it's possible that no data has been cached and it then sends a request to the database and gets the data from it. So a lot of people often pose this question that, but we still have to make a lot of calls to the database, right? And we still are getting all the data from the database. But the thing is, often the distance between the server and the database is quite small. But what is big is the distance between the server and the client side, because the server and database are usually hosted on the same machine most often. Like if you have a project and you put it on AWS, you are mostly always going to put the server and the MongoDB on the same S3 bucket, right? But that's not going to be the case with your client. You could have your server set up in New Delhi here, but your clients could be sitting in San Francisco, and that's a long distance. And basically, obviously, that's not exactly how sending requests and getting data works. But what I'm trying to say here is that in this case, between a server and a client, the size of the payload matters way more. And that is when it reduces the amount of data it has to send over. The exclamation mark, it does not mean primary key. It just means that this field cannot be null. So the concept of primary key per se does not exist in GraphQL. Yes. How can we get the whole object? For example, all lifts. Do we have to mention each attribute? Yes. Okay. So yes, you do. And I know that this is often very annoying for a lot of developers, because they're like, I need everything, so why do I have to declare it? But then again, by definition, GraphQL is the scheme definition language of GraphQL is very declarative, and it requires you to write all the things again and again. Okay. So talking about that, right? Because we're talking about repetitive things and redundancy. Let's go here. Let's go back. And let's say that let's look at more queries that we have to play around here. We can get just a particular lift, or we can just get a particular trail using these two queries. The lift count will return a count of all the lifts that we have. And we have trail count, and then we have search. Okay. So in all lifts, we are getting things like status, capacity, night, elevation gain. Okay. So let's say that I want to, let's say we just have like these two things. I'm going to do like a very stupid example, but it's to explain a new concept, which is called fragments. So, comment let's talk about a fragment. So what fragments do is they help you to not repeat a lot of these field names multiple times. So let's say that I want to build a fragment lift on lift. Lift is the type that we already have. We can see it here. It is in the schema we declare a type lift that I spoke about before, right? You can create these types. Okay, so yeah, so okay. We create a fragment lift on lift, and we say that on the type lift, I'm creating a fragment out of it from which I get the field's name and status. So we can see that in these two fields, name and status were similar, right? So then I don't have to repeat name and status again, and I can just, I don't want to delete everything. I can just be like dot dot lift because it's a fragment that I have and I can just use it. And then here, instead of typing name and status, I just do lift, and then I can do get lifts, and gets me the name, status, and the capacity, and I can do lift status. How this helps is, say I always know that there are like certain fields that are common, but if things about my data type change, I know I don't have to go and change the attributes everywhere. I can be like, I can just add the fields here, and next time that I run get lift, it's going to add the night field to it and night field here as well. So this is how fragments help. Again, you could then create a fragment which has all the different fields here, and then you can just call that fragment, because it's possible that in there are other situations where, say inside trails, if you have a field called lifts and you want to get the list details of all the lifts there, then you wouldn't have to repeat all the different attributes around lift here. You could just take this fragment and you could just call it here, and all the changes that you make would happen once. So it really sort of helps with redundancy to use fragments. They're quite useful. Yeah, so I hope that sort of helps with the question. I know it can be like really frustrating, but that is the way few things work in GraphQL, which can be quite verbose. But I think that helps with reducing errors in any way, and it really structures things down. Okay, so moving on from that, let's talk about, now these are very simple queries, right? But very often you have parameter based queries. Like, what if I want to get a lift, but I want lifts that are, say, that I have a particular ID for it, or if I have a particular status for it. Like, how do we do that? How do we get around it? So there are a lot of different things that can be done. Okay, let's see here. Here in all lifts, okay, let's read so best thing, the one thing that I really love about working with this is the documentation that you just get with it, right? So if we look at our all lifts queries, we can also give it a status, and then it would only give us lifts of that status. So if I were to specify that here, then we can see that, okay, another thing that okay, there's a lot to cover. We'll slowly go through all of it. Here in status, you can see the type lift status, which is actually an enum, and you can define enums in GraphQL. All you have to do is just like define an enum by saying enum, give it the name, and then give it the different values that you want it to hold. So here I can try to get all lifts that have a status open, and then it's just going to, so okay, right now here we can see that when I ran the all lifts query, it gave me everything like closed, and hold, right, and open. Everything's there. But now if I want to see just the lifts that are open, I can give it a query here, and then this will be open. This will show me only the ones that are open. Another thing is you can actually have variables in your front end, and you can then just send those variables here in the status field, and it would just give you, so basically you don't have to hard code it. That's just an example here, and it doesn't have to be that way. So that's one thing about arguments. Like, let's look at the other things that we have here. For example, in the lift, we can get one particular lift, and this is where a fragment like this can be helpful because the fields of the lift remain the same. And let's say if I want everything, I can just have a whole fragment for it, and I can just reuse it in all lifts or when getting an information about a single lift, right? So let's try to get that. Let's get query get single lift, and here we will use the query which is called lift. And you can see that as a argument, I need to provide it ID. Now let's check the ID of something that we already have. So that makes it easier for us to run things. And here as a response, I will just call for 3 dots always for fragments, and then I'll just get all these fields in the fragment, right? And this ID, we don't know about it here yet. So I'm just going to delete it, else it's not going to let me run anything. Get lifts, and we can see, wow, they have very interesting ID names. Let's say we want prickly peak, and I want a prickly peak, and it would be ideal to put it here. Okay, and now let's get single lift, and we get all the information. Now what if the fragment that we have does not have all the fields that we need? For example, if we create a we create a fragment in a way such that it doesn't cover all the fields that we have, and there is more information that we need, right? Because if we look at lifts here, they give us a lot more information. We get to know about the elevation gain, the trail access, and stuff like that. So if I want to know about the elevation gain for just the single lifts that I get, I can just add that field here. So, okay. Now, if we noticed, within lifts, there is another field called trail access, which gives us a list of all the trails, right? And if we look at a trail, so if we click here, it will then give us more details about what a trail is. So now we see that a trail is actually also like a big type, and it has all these different fields. So again, if we want to get, I need to stop just swiping left. Okay, so now let's say when we're getting the single field, the single lift, I also want to get the trails that I have access to. But now it won't give me anything if I don't ask for what exactly I want from it, right? Here it gives me an error. It says that trail access is of type trail, and you must select the subfields that we need from it, basically. So I'm going to go here, and sorry, this is not what we're looking for. And from trail access, this will be a good time to create a fragment on trail. So we do that, and I want to get the difficulty. I want to understand what's the name of the trail and what difficulty trails are available. And here I just do a trail, and now when I click on get single lift, it gives me the lifts, and it shows me that these are the different trails that you have access to. So right here, you can see an example of how this is helping us create. So there is a relationship between lifts and trails, and that has been created by actually referencing trails in lifts, and even we have access trails in lifts, and similarly in trails we have also a field of access by lifts. So there's a two-way connection here, which helps to establish a relationship. So for this, now you can see, because of the ease here, it's very helpful with GraphQL. But this is again something that doesn't come just by default, and it's a design choice that has to be made as a developer. So if there are any connections that you have between different data, that connection sort of has to go two-way for it to be able to help you. Okay. Glad that. Do we have any questions around here? I would like to take a 5-minute break to just go over, because I know this is a lot of things that we are suddenly learning about. It's a very different way of thinking about APIs. So if we have questions about it, I'd be happy to first discuss them. Anybody with any questions, thoughts? Need to stop doing this. Okay. Okay. Because once we are done with querying a little bit, can we use multiple conditions? Yes, so it's completely like a design choice. In the arguments here, we can have more than one argument. Right now I can't demo that because that's not okay. If we look at the docs here, we can actually see the different arguments that all of them take. So by design here, they have not, okay, yeah, we have this here. Let's do that. Let's try to think of multiple conditions. Search for night trails, right? And then here there is a term that it wants us to use and a status. So okay, here it also gives you in words, and this was not written by a human being, this was auto generated, that returns a list of all the search result objects based on term or status. So here it could have, you could have multiple conditions. Okay, we will discuss unions also. Unions is another tricky thing. This doesn't explain multiple conditions, but what I mean is that if as a developer you want to have multiple conditions or multiple filters put up, you can put them up here. You can also have a field called elevation gain, and once you implement this in your backend server, you can call queries that way as well. So this also brings me to talk about a little bit about how query types are defined. To define a query type, basically, what you'd want to do is have a structure that looks like this. So for a query where we want to say, let's say we have, let's say we have all trails only. And here we want to allow users to talk about the status, but at the same time they can also talk about the difficulty. And the difficulty type is, let me get this right, string. Okay, so we get a string here, and we know that this can't be null, so we put these to be not null. Like, see here, when there is no exclamation mark in all trails, even when I do not put a status, it still gives me results, because then that means that that argument is not compulsory. But if I say that it is compulsory to give me a difficulty string, then it won't process the query till the difficulty is not been provided to it. And then after that, so this defines the name of the query, the different arguments that it can take, and then here we are going to define what it gives you. And here it gives us a list of the trails. So trail, and none of this can be null. So this whole format is sort of used to define what a query is, and this just lets the GraphQL schema knows that this is the schema on which you're going to create your query. And then later you create a resolver, which helps you to get this required data from the database. How you implement the resolver completely depends on the platform you're using. Okay. Which will be best, Django or GraphQL? So GraphQL is now competing with Django because there are actually implementations of GraphQL that you could use on Django. So GraphQL, as I mentioned before, is a query language, and it's a specification. It cannot do any computations by itself. It's not a package on its own. So Facebook in 2012 just released a specification about it, but they didn't really say that, okay, only these languages can use it, or the packages can be built only this way. So all programming languages can try to implement GraphQL packages. There is a Python package called Graphene. I've not used it very often, but it's a package that is used to implement GraphQL on Python. So if you want to build something like LinkedIn, yeah, you could build it completely. You can choose the front end of your choice. You can choose a backend server of your choice. And to connect these two, you can either connect them using a RESTful API, where you would send requests and responses and HTTP. So there'll be HTTP requests and responses going back and forth. If you were to use GraphQL, then you would be sending queries and mutations to make your work. Speaking of mutations, let's talk about what they are. So far we've talked about how to get data from a database, but a user also needs to delete stuff, add stuff, edit stuff. How do we do that? Those things are called mutations. So we have some mutations here that we can try to use. Let's look at them. So we have two mutations. One is called set lift status and one is set trail status. So let's just try to take a lift. So far we did this query, right? We took prickly peak and it had a status open. Now we realize that it's not snowing enough and we need to put this trail on hold. Put this lift on hold. Then we can do that. Okay, let's try to do this. Right now our mutation cannot have any, no, actually we have to give it a name. Change lift status, and here we say set lift status, and it asks us for two things, ID and status, right? So the ID is prickly peak and the status that we want to give it is hold. And even when you're doing a mutation, you can tell the server that once you've mutated, send me back this much detail about the data that I've changed. So I might want to get the elevation gain back, and I might want to just check the status if it has actually changed. So if I now go to change lift status and if I run this, it tells me that the lift that I've just put on hold has elevation gain of 1700. Again, here is also a place where you could use the fragments. So they're just like usable everywhere, like here. And if I am to go back to this query that we created, which gives us only all the open fields, and we go to get lifts, you see that prickly peak is not there anymore. So yeah, that is how mutations work, where you again give mutations a name. From calling them, like from that perspective, they are very similar to queries. We just call them mutations because that means that our data is changing. Here right now we used it to update information that was already there, but it can also be used to like add more data. So right now that does not exist, but let's say we had something, we had a mutation to add it. It could look something like this: add lift, and then this would take a whole object of lift and it would ask us for the ID, the status, and we would give it all the details in the form of an object. And okay, maybe we wouldn't give the ID, maybe we would give it the name, and then we would want to get the ID of the newly generated lift. Again, like I mentioned, we can't do this right now because that's not an implementation that exists on the server side. But it is possible in theory to implement it on any platform to add documents as well as delete them and make changes. So that is like mutations are actually pretty simple, and it's like not very complicated on that. Can we get data from a blockchain using GraphQL? Okay, so interesting thing. I personally never tried to do that, but I do think you can. My reasons being, because when you are using GraphQL, right? So what GraphQL tells you about, what it restricts you with, is it tells you that this is what a query looks like, this is what a mutation looks like, but it doesn't tell you how to resolve a given query. So what this means is that I can have a query called, say, get trails, and so okay, let's talk about, since we're talking about blockchain, we could have, say, query, and we could call it get transactions, and there could be a field there could be a query on our backend called all transactions, which on giving it, like, and then it gives us the ID, sender, receiver, public key, everything. And then, so basically how you would implement this in the case of a blockchain is that when this is being resolved, so when you want to resolve, your GraphQL schema knows that there exists a query called all transactions, and now when you're resolving all transactions, you can just make a call to your, like, you can just connect to your blockchain API and you can get the information from there, and you can give that information to GraphQL. GraphQL will then handle the format in which the data needs to be sent. Does that make sense to you? Like, am I clear about that? And since you have since you have blockchain APIs in JavaScript, in Rust, I'm sure you can just like use them there. Yeah, So, do we have more questions around mutation? I would like to take a small 5-minute break, go drink water. And if you have questions around any of the things we've discussed here, please let me know. I'm going to take a very short break. And when I come back, we can talk more about queries and different types of interfaces and union types and more discussions and questions then. Okay, hey guys, I am back. So I saw a question here. Okay, so I get this error when running the mutation, cannot set properties of undefined setting status. So the thing is, if you try to set properties of an object that doesn't exist, it's going to give you this error. So if you see the mutation, let's go here, then it's, are you setting the ID property? Because you can't change the status of a lift that you've not defined. So it needs to be like a lift that has a particular ID. So can you make sure that you are setting an ID of a lift that actually exists? So to see what lifts exist, you can actually run the all lifts and like, let's see here. This, did you mean, oh, all transactions, that thing, right? So here I wanted to get this one, get live status. Let's try that. And here we have all the different lifts and their IDs, and you can just see their IDs here. So try to use any one of these. What was the typo? I'm curious. Glad to know it works now though. And yeah, okay. So now I want to talk about two things. One is interfaces and the other is, oh, you prickly pear. Oh, okay, that is funny. Okay, yeah. So the two things that I want to talk about are unions and interfaces. So let's talk a little bit about that and see how they would work. So let's say that you have, it's a ski resort, right? You need different people to run the ski resort. But okay, so when we're talking about any particular entity, like, okay, I am sure many of you would be familiar with the concept of object oriented programming, where you have you also have interfaces there and you have classes there, which are used to combine a lot of things that have similar properties. So let's say that you have 3-4 different kinds of employees in your ski resort, but somebody works as a lift operationer, somebody works as a trail worker, somebody the reception staff in the resort. Then how do you, but so they have a few things in common, which is, say, their names, their IDs, their salaries. But a person who works in the lift might have different information regarding them, and a person who's working with trails might have, like, there's like different information that you need to store about them. So what do you do in those situations? So we can just talk about that and use interfaces to actually solve that problem. One way to go about it would be that you take say one employee and you create all the different possible fields in it, but then that would mean that those fields remain null or empty for a lot of people, and this is just not like a good data practice, right? Because you get so many things that are just not needed, or they are just, what if I end up setting a property for a trail worker, which can only apply to the live staff? You cannot put it on a trail employee, right? So how do we differentiate that? That is when we can use interfaces. So it's an interface of, let's say we have an employee, and employees have their names, their IDs, their salary, and for everything we'd obviously have to define the data type. String, this is compulsory. ID, this is also compulsory. This is a number, and yeah, let's say this is common. But now we have another interface or a type, which actually we have a type which is ski lift staff, and we implement, I think the word is implements, yeah, it implements employee, and then that would be name, ID, salary, and we have ski lift ID, and that is another ID here, or we can just say lifts handled, and that's a set of all the lifts. Okay, so one thing that you're going to notice here is that I have to repeat name, ID, salary. This is again yet another tiny annoying thing about GraphQL. Even when you're using interfaces and you're implementing interfaces, it needs you to tell it how you're implementing that interface and all the fields that you're using, because GraphQL just does not allow for any leniency anywhere. It's very verbose, and you need to define your schema pretty thoroughly. It's a good thing, but sometimes can get annoying and can also be a bad thing. So that's just like a tiny thing I just wanted to talk about interfaces. Now let's talk about something more interesting, is union. So in unions, you can actually say we have a search field, we have a search query, right? And in the search query, since we have this whole database which can have different things, so is it Golang? So you can use GraphQL with Golang, but this is not Golang. This is just GraphQL's query language. It's how in any language you can sort of run a GraphQL query. So this is the specification that you have to use. But great thing, it can be used with any language using the different packages that are built for it. So like there is nothing particularly like there's no official GraphQL package per se, because every language can try to create a GraphQL implementation on top of it. So for Golang also, I'm pretty sure GraphQL packages exist. And very interesting thing, if you are working for a language for which a GraphQL specification package does not exist, you can implement one. So that's cool. Yeah, okay, so if you're here and we're talking about union types, right? And now I have a database which has different kinds of data. So the search result can actually be something that's, it can either be a lift or it can be a trail. So how do we go about queries like that? Because I told you that queries here, say an example of all trails, had a structure like this, right? Where yes, sorry. And here we have status, and it takes this thing called lit status. Okay, so this is how we define queries. So now if we had a search query and it took a term which is a string, and it took maybe say status, which is here trail status, what would this return then? It could be both. So what here ends up happening is we create a new type, and let's say we call it search results, and that can either be wait, sorry, I am confusing something, so let's go search up the syntax here. If we look, so this is Apollo. So Apollo GraphQL is basically, Apollo as a company works a lot with GraphQL, so you'll find a lot of their packages, especially if you are in the JavaScript ecosystem. This is the sort of more official GraphQL website to learn about the basics of GraphQL. So let's say that I wanted to talk about union types, right? Okay, sorry. So we don't call it a type, we call it union. And then search result can either be a trail or it can be a lift. Either is okay. So now here in the case of our search query, the return type for it would be I want to make this capital since all names here are capital. Here I will make it a list of search result. Okay, so this is how it would happen. But now let's try to run this and see how we would actually get data out of it. So we know we can remove this, since if we go check our docs, we actually have a query type which is called search results, which is a union of lifts and trails. So this means that the query can give either results. Now if I go on query here, and if okay, this needs to go off. Now I want to do search query, and here here we have a query which is called search, and let's say the term, we want something starting from S. That's all we put here. Now, as like I'll just put ID here, and let's get the results, search query. Yeah, okay, so now it tells us that it can't query the field ID on search result, because if you think about it, coming here, search result doesn't have anything called an ID, right? It only has lifts or it has trails. So then what we do here in the case of union result is we do inline fragments. What that would mean is we create a fragment here on lift and we ask for the ID. And say we also, okay, if I were to just remove this and if I were to ask the type name here and I get the search query, so it actually gives me the type names of all the responses we got by the, if we to just see what contains S, these are all the different type names that we got. So this is one field that we can get. But if we want to get something specific from lift or trail, even if it's a common property, like I tried to get ID, and ID is a common property in both lift and trail, we can't just directly access it. We have to create inline fragments on the two objects, which are lifts and trails. So this is what it's going to do. This fragment is only going to run on lifts, and if our result is a lift, it's going to give me the ID and the name and the elevation gain. Okay, but now here in the result we see that we also have a lot of trails. So what we can do is we can create another inline fragment on trails, and here let's say I don't get its ID, I just get the name and I get whether the trail is open or not. So we get the status. And now if I try to run the query, you can see that for lifts, I'm getting ID, name, elevation gain, everything. But for trails, I'm only getting the name and the status. So let's try more stuff here. Like, because we know another thing that I can put here is status. And if we come here and check the status, so this only applies for lift status. So here, if I write open and then I run this and I do search query, then I only get the lifts. So, okay, let's do this. Let's put status here. I'm going to close this and we have the term S, right? Because they return conflicting. Okay, wait, what? Oh, okay. So yeah, so now you can see that the error here says field status conflict because they return conflicting types, lift status and trail status. So you can see on both lift and trail, we have this field called status, and it's going to confuse. So if I just, so let's say for example, this is something that, okay, we have elevation gain on lift, but we have only name on status on trail. But let's say we had the same fields here, ID, name and status, and ID, name and status everywhere. And if now you were to, like, if you didn't have the type name, it might like confuse you what kind of status it is. Because in terms of ID and name, we know ID is of type ID and name is of type string. But with status, in case of a lift, it's a lift status, and in case of a trail, it's a trail status. So let's come here and see that. So here we have a lift status, which has this enum, and then we have a trail status. If we go there, it only has like two enum properties, like open and closed. So these are two very different data types that we're talking about here. So it's important to differentiate between the two. So what we can do is we can use an alias here, and let's make an alias called lift status. So the field status is actually going to be called lift status right now, and this field is going to be called trail status right now. So let's do that and let's run the search query. And now we can see that we get the lift status and the trail status and all of that. And now let's try to get only all the open status. So now, because here when you see status, the data type of status is only lift status, so it's only going to run this sort of filtering on the lifts. So when I put open here, even though trails also are open and closed, but when I run the query, it's going to give me all the different trails that it has. And but like the, let's see, if we do hold, and then there are no lifts around that. If we do closed and search query, and it then shows everything that is closed. So I can remove the term here, and I can just try to get all the lifts and trails that are closed. And I just want to check this one thing. Yeah, so like, because trails can't have lifts, trails can't have the status hold, so it just shows all the lifts only with hold. So do we have any questions around unions and fragments on union queries here? You're free to ask any questions around any of this if I was like too fast, or if a lot of this doesn't make sense because it's more abstract, because you're not seeing the code that is running behind search, so it can feel very foreign to try to understand it, and I completely get it. So yeah, what are interfaces used for? Interfaces are basically used when you have when you have different types of data, but that data has some properties in common there, and it falls sort of under the same class. Say you have teachers in a school, but teachers that teach different subjects then have like different details that they all need. Or a very common example that's used every time we're taught programming is to take animals. Now, animals, you can use an interface called animals, but okay, interesting question. Can't we use a fragment for that? So a fragment, what it does, it's only a subset of a big type that we have, right? So if I have the lift type here, and if I want just these fields out of that lift, that is what a fragment is used for. What an interface is used for is to define the different kinds of types. So it helps in the type definition, because again, if I were to, I think animals actually work very well because everybody understands animal. If I were to have one type of animal and we give it all properties, we give it name, and then we also give it things like barks, meows, like say if we want to see whether the animal has this property or not, or we can give it I think barks, meows, we can use that. We'd have to sort of here declare every different property that we can think of any animal in this one type, and this makes it like a big verbose type, and again it might not apply for every interface. So instead what we can do is we can take the common properties here, and we then create a new interface. Sorry, we will make this an interface id, since let's just do this religiously. And now we have a type dog that implements this interface of animal, and here we again, like I mentioned before, we'll have to rename all of this, again explain it, and then here we say it barks. So barks, let it be a boolean, and let's just copy this, and let's say we have a cat, and or maybe we want to say if it has stripes or fur or whiskers or whatever. Basically my point being that we have these common properties which we define in an interface, and then we can define different kinds of types based on that. We just have to repeat this definition here. But okay, you might ask me then, why should we can just skip this and create different types of dogs, cats, and all the animals as a type, but then there'd be no check between them. So if say you were to change properties here and they were missing in dog or in cat, there'd be no way to check that. There'd be no type check there, and it's possible that there is some property that was supposed to be common between two animals, and because we didn't change it everywhere, it didn't even give us an error that you are missing this particular property. Yeah. So does that make sense? So it's just like in Java. Yes, yes, yes. Exactly, very much. Oh, I am so sorry about that. Is anybody else facing that? I know that like live streams can be very weird. They take a lot of your internet. Maybe there's some problems on my end, but I hope that does not affect your understanding of GraphQL. Uh, yes. Oh, good to know that. Thanks. Okay. Okay, so these are all the query schema definition language related things that I wanted to talk about. One thing that I would like to make clear is that all these queries, you actually run them on your front end. So don't forget about that. These are not queries that you write on the back end. Like this implementation here, you would take it as is and say, so okay, what happens in JavaScript is you often wrap these queries around this tag called GraphQL. And this GraphQL comes from the GraphQL package that there is in JavaScript. And then you'll put the whole query inside of it. So this is how it works. So you see that this is something that runs on the front end. And what goes on the back end is things like type definitions. So everything that you see on the docs here, this schema here that you see, which has all the types, these enums, this is something that goes on your backend. So this is where you do a schema definition of for the GraphQL API, and then the type of these queries, the mutation type, the and then the resolvers for these queries and mutations. Again, all of it on the back end, but queries like this always on the front end. Okay, so that is mostly everything I had in mind to share with all of you. Do you all have more questions that you'd like to go through? No. So that is not how GraphQL works. So the GraphQL API actually handles all of this for you. So the front end says, like the front end communicates to the back end that I need A, B information, and I don't care about the D, E, F, G, H you have. Like the front end maybe doesn't even know that it has more information. And the back end's going to be like, okay, you only need these two things. So in the payload, it only sends it those two things. So you don't need a lot of bandwidth because the front end only gets what it's asked for, which is, in my opinion, it's actually a beauty. Again, I'm not saying that this cannot be implemented on RESTful APIs. You can very much do that. You can put like filters on your queries, and you can, define your queries to only have certain things. But then that can become very cumbersome for bigger projects because RESTful APIs are just not framed with that use case in mind. There is whereas GraphQL specification was created when this need arose, that we have a lot more data coming on the front end that we just don't need. Popular projects that are using GraphQL APIs right now, top of my head, is GitHub. GitHub moved their API, like the public API that they have to use GraphQL. I also know that Airbnb probably has now switched to GraphQL. Yeah. So, yes. Yeah. So, what other questions do you all have? Let's talk about them. And if anyone wants to come on stream and talk about it, you're welcome to do that as well. Let me know in the comments if anybody would be interested to come and have a conversation. Or you can just like keep sending comments and I'll keep talking to the comment section. That's perfectly fine as well. Also, okay, so a few good resources for all of you to know is this website 100%. It's a more community run GraphQL website, and I would say it's a very good place to start. Like I was mentioning here, places that use GraphQL. So the URL is pretty straightforward. And here, so if you go here and if you click on learn, it actually like teaches you about a lot of these things. You can see that we covered the fields, arguments, aliases, fragments. We do not cover variables. We can cover variables. Okay, so let's look here. Like I mentioned, that you can have like queries and arguments in. You can have arguments in your queries. The good thing is that you can actually, so let's say from the front end, if I want to send like a variable here, I can have like a variable, and then here I can just use the same thing. Sorry. So there is a variable ID, and we have prickly peak. Wait, I am using this incorrectly. Yeah. Oh, this is mutation. But let's see. No, I'm doing it incorrectly. Okay, so basically you can provide, okay, here it is defining the type. So here it just says that the variable ID is of the type ID, and then we are giving this variable to our to the query that's actually going to the query that actually exists in the backend. Like I mentioned, that the name that you give here is something that exists on the front end. It exists on the client side. So from the client side, when you use when you say you have different variables that you want to like send this to, so you first define a variable here in the parentheses. You call, like you say that we have ID and the data type is ID. And then here when you're sending it, instead of sending a value here, because last time we sent a value inside parentheses, but instead you can also send variables. So that's one thing I forgot to cover, and that's that. You can give it default values. So here, by default it can be called prickly pear. So change live status, cannot set properties. So I definitely got the prickly, oh shit, it was prickly peak. Prickly pear was the error that somebody made. See, it sticks. Yeah, so here you can see I can now change it to open, and voila. And we can just either, this is a default type, and usually you'd send the variable here from your client-side code. Okay, so now coming back to a brief overview of what we're seeing here is that, yeah, we learned about mutations and inline fragments, right? So we've covered all of this basic ground around queries and mutations. So you're actually you're pretty much covered there. And we also talked about the type system, the query mutation types, lists, enums, unions, all of that stuff. What you can do now is maybe read a little bit about thinking in graphs. The reason, the reason why I think that this is an important blog, like it's an important article to read, is because now you suddenly, the way of your thinking around GraphQL API projects has to change a little bit from before, because in when it's a GraphQL API, you have to think of everything as everything as a collection of data of different types. Those types are very important, and then those types are all connected to each other in some way. So in that way, it's like a graph. So yeah, this is just an important read to just go through it and understand it when you're like making decisions about how to design, because designing your schema is crucial, like it's very important. And also do read about validation and how to validate data. You can do all of that. So now once we are through with that, and here you can then go to the code tab, and you can actually read about and learn how to use it with different languages. And you can see that there are actually a lot of languages that do support GraphQL. JavaScript is actually very common, and this is the GraphQL.js server. This is the GraphQL orgs GraphQL implementation. So, and Apollo server is the one that's run by Apollo, the organization. So if you're looking for a little bit more, this has a lot of bells and whistles. Because Apollo makes a lot of packages that they're doing a lot of interesting stuff, but it can be a little bit of overkill for projects that are more they're more basic. They don't have like too much stuff going on. You don't need a lot of caching, data loading, things like that. For that, GraphQL.js is just like a simple, clean implementation coming straight from the specifications. So it's just very clean to use this in, say, your Express server. You can just do that. And there's also GraphQL Yoga, Express GraphQL, which you can use with Express. And yeah, basically you can see the list. So okay, one other thing, final thing, without talking about which I cannot like end this conversation here, is that one thing you should keep in mind is when you're implementing GraphQL in your projects, you have to remember that you have to make adjustments for it, not just on your server side but also on your client side, because you saw that we're not just sending plain HTTP requests, but we're trying to send queries, mutations in the GraphQL form. And if you use a package or a library on your front end, it makes the process easier and it just gives you access to a lot more features. So for that, we use client-side libraries, which are given here. There is Apollo client, there's Relay, AWS Amplify. I personally have worked with URQL before and I actually enjoy it because it's again very simple. You can understand their architecture quite easily. You can just go through their whole documentation in a few hours. It's not very long and problematic. And just like there is also a hooks API now for anyone who wants to use it with like React hooks. So there's that. A lot of stuff going here. Most of these libraries are also like open source. That's pretty cool. Then a very important tool that you should use when you're getting started with it is GraphQL. GraphQL is what helps you give this playground. So it's good to like test your code there. Yeah, so it's like you don't have to write on the queries on your front end and like test on your graphicals, like on the visual side of things. You can just test if it's getting you the right data. And you have the code generator. It helps you a lot with if you're using say TypeScript in your project and you have your like your GraphQL types and then you have TypeScript, right? So it helps with generating a lot of code for TypeScript for your code to be like type safe and like very secure and well written. Again, it all depends on the usage. So yeah, and you have the CLI and there's like a bunch of stuff you can go here. Don't get overwhelmed by this. You don't need to use all of this in your project. I personally have not heard of all of these libraries or I haven't used all of them, but it's just about understanding what you want and what you need, and you can just find the support here. And this FAQ section is also sort of interesting to go through. So just go through this graphql.org website for like next steps. I would say pick your language, pick whatever language you're familiar with, and then try to create a GraphQL API in that language. Yeah, that is all for me, folks. I am open for a Q&A for like the next 10 to 15 minutes. So go for it. And again, if there are any things that you need me to repeat, I am more than happy and available here to repeat them. I am on stream for the next 5 minutes at least. And then I'm going to give my throat a break. I do realize I've been talking for 1.5 hours. That is a first for me. Okay. So other cool stuff that I can think about. Yeah, actually, I think the Apollo server is pretty good, but this is for JavaScript devs. Let's see about Python devs, since we have a few of you. See, for server, you use Graphene or there's Strawberry. And yeah, I also read that Ariadne is also doing pretty good. And you can see the last release of it was made like 4 hours ago. So everyone's like sort of working in this field. There are so many new packages and libraries here. It's a good time to try to use it. And it's not late. Like people are still catching up to it. So it's just like you're there right when things are happening. Okay, we're here. We also have Go, we have Rust, we have Julia R for all our different developers. Okay, so question we have on the database side, is there any way to track what GraphQL queries are the most used or most accessed so you can try and tune the database indexes? That is a very interesting question. So that is actually not something that GraphQL offers in my understanding. But because again, like GraphQL as a language is nothing, right? Like, I mean, GraphQL as a language is just a query language. Everything depends on how different packages implemented. So you can always create an add-on on top of any package that already exists to give you more details. What a lot of packages do help you with is caching. So a lot of times they don't even like make database calls. And but this is actually a very interesting question about tuning database indexes. I've never thought about it before, but because if there is not existing support in any package, you can always create an add-on that lets you sort of, where you try to keep track of it and then you try to tune your indexes around it. Is that too deep a data? That is a database question, yes, and very deep. But I thank you for the question. That's very interesting. Let's try to search about it. Because I mean that's what I do if anyone asks any question. So let's see. GraphQL database index tuning. Let's see. This is performance explanation, searching index. This is an interesting read by the Netflix technology team. So round it's creative on the shore. Also challenges of searching only. Okay. Yeah, okay. Since we already use GraphQL, how can we leverage it to index our data? I think that is what you're asking about. So, yeah, we can update our GraphQL query slightly to retrieve a single creative and all of its related data. Then call that query once for each of the creatives in our database, indexing the results into Elasticsearch by batching and parallelizing the request to retrieve many creatives via a single query to the GraphQL server. We can optimize the index building process. So Elasticsearch has a lot of customization objects when indexing data, but in many cases, the default settings give pretty good results. At a minimum, we extract all of the different types of definitions from GraphQL query and map them to a schema for Elasticsearch to use. The nice part about using a GraphQL query to generate the schema is that any existing clients relying on this data will get the same shape of data regardless of whether it comes from GraphQL server or the search index directly. Once our data is indexed, we can sort, group, filter. Interesting. So if we basically use Elasticsearch along with GraphQL, we can actually use like GraphQL to index different fields. Again, I have heard of, now Elasticsearch lies in the category where I've heard about it, but I've not personally used it. But let's try to get Elasticsearch to index data. Elasticsearch, how to index data, yes. Wait. Index database with GraphQL. Okay. So this seems to be an interesting article that's talking about it. And okay, I cannot skim through this article in a fast read right now, but I do think what you're saying is possible, and you can, I'm gonna send this article over on Twitch. You can open this link and read it up to understand more about how Netflix is actually using GraphQL with Elasticsearch to better index their data. Thanks for the question. That was actually a very good question. It's like, yeah, same. And I think now after this, I'm very curious to implement Elasticsearch on something and see how it like improves performance. So thank you. Really, thanks a lot for that question. A very interesting line of thought that I hadn't thought much about. Folks, if you have more questions and, even if I can't answer them, please, I mean, obviously it doesn't help you much, but we can always try to go ahead and search it online and like try to have a conversation and understand it better. That's the whole point of doing like a global hack week. And this is why I personally love being on stream as well. It's like when I do a stream, I get to learn so much through the interaction that I have with everybody. It just helps me to make my concepts even clearer than they were before. So it's actually like a really nice thing that I like doing with the community here. So thank you all for like sitting here and attending it with me. um I'm going to call it a day on my end because I don't see more questions coming over. If you do have more questions or if you want to discuss anything, you can reach out to me on Twitter. My username is Manya_AG, and it was actually a pretty cool session to host with all of you. Thank you all, everyone, for joining. Bye bye, and have a very nice day.